In this video, we're going to be dividing radicals. So one good example would be something that looks like this. So the square root of 72 x cubed divided by the square root of 162 x. And we kind of did some of these in the previous videos, but we're going to just expand it a little bit more. So how do you divide two different radicals? Well, one of the first things that you do, you can actually make this into one whole entire radical. So square root of 72 x cubed divided by 162 x. Okay. So then what you want to do is you want to work with everything in the inside. So when you work with everything in the inside, it'll be much easier for you to do these problems. So one thing that you can do is reduce the 72 and the 162. So 72 divided by 162, and you can use your calculator if you want when you're doing 72 over 162. That's going to reduce to 4 over 9. Okay, so this is just 4 over 9. Okay, and then you have here x cubed divided by x. Remember that you can just subtract them. All you're just going to get is x squared. Okay, so what am I left with? Well, what is the square root of 4? The square root of 4 is just 2. The square root of 9 is just 3. The square root of x squared is just going to be x. Okay, that's going to be my final answer. Now remember, we don't care about absolute values right here. Usually you would have an absolute value there, but in this case, we're just going to assume that x is positive. Okay. All right, and now let's do another one. So let's say now we have the cubed root of negative 250 mn to the negative 2 divided by the cubed root of 2m to the negative 2 n to the power of 4. Okay, so let's say we did something that looked like that. So the first thing that you want to do is put everything under the cubed root. Okay, so negative 250 mn to the negative 2 divided by 2m to the negative 2 n to the power of 4. Okay, so the first thing, let's divide out 250 divided by 2. That's going to give me negative 125. So this is going to be negative 125. That came from dividing these things together. Then let's do the m's. So this is going to be m. So this to the first power, so it's going to be 1 minus a negative 2. That's that portion. That's this blue part. So this part is going to correspond with this part. Okay. And then the other part, which is going to be this color, is going to be the n's. It's going to be n negative 2 minus 4. Because remember, we are subtracting them. Okay. All right. So what is this going to give me now? So I'm going to have the cubed root of negative 125. Okay. This negative and negative is going to turn into a positive. So I have m to the power of 3. This is going to give me n to the power of negative 6. Okay. And now I can further reduce this a little bit before I do the cubed root. I'm going to have cubed root. Since this is negative, I can bring it to the bottom, and that will make it positive. So you'll have negative 125 m to the power of 3 divided by n to the power of 6. Okay? And all we got to do is now just take the cubed root of all of these things. So you're going to take the cubed root of negative 125 m to the power of 3 divided by the cubed root of n to the power of 6. Okay? So the top part, 125 is just basically 25 times 5. So that's just going to be negative 5 times 5 times 5. Okay. Whoops, messed that up. This is just going to be negative 5 times negative 5 times negative 5, right? Because negative 5 times negative 5 times negative 5 is going to give me negative 125. Then you have 3m's, and then the denominator, you're going to have 6n's. 1, 2, 3, 4, 5, 6. Okay? And now let's just take out a couple things. So here we have a negative 5's. We're going to take that out. So we're going to be left with a negative 5 on the outside. You have 3m's. That's going to be taken out. You have 1m there. Okay? And then you have nothing on the radical and the numerator, so you're done. Now here you have one triplet of n's and another triplet, so you're going to have 2n's. So it's going to be n squared. Okay, and this is going to be my final answer. Okay. Okay. So these are two different types of problems. If you were still confused, just go ahead and rewind it and then and try them out again. And what we're going to do now is we're going to do something called rationalization. Okay. So rationalizing. And right now it might seem a little bit useless of what rationalization is and why is it useful. Why do we want to write it like this? But rationalization. But it's used in a lot of areas in calculus. So it might not be helpful right now, but it will be helpful soon. Okay? So how does rationalization work? Okay, so usually you're going to encounter problems that look like this. 4 square root of 3. Okay? And what we do not want, sometimes it's very difficult to work with square roots on the bottom. So what we want is, we do not want a root on the denominator. Okay, that's not what we want. Instead, we want it in the numerator. It's going to be much easier for us to work with that. So how do we do this problem? So, well, we have a square root of 3 on the bottom. What we want to do, we want to make it into a perfect square. So what would make it into a perfect square? What's something that's missing? Well, square root of 3, well, I don't quite know what square root of 3 is. It needs another pair. It needs another pair of 3. That way it can be, it needs another 3 to be a pair of 3. So what I'm going to do, I'm going to multiply this by the square root of 3 to both top and bottom. Because then that's going to give it another pair. So, and notice I'm just basically multiplying by 1 because square root of 3 divided by square root of 3 is just 1. So I'm just multiplying it by 1. I'm not really doing anything. Okay, so now what's going to be left, I'm going to have on the top 4 square root of 3 divided by square root of 3 times square root of 3 is going to be square root of 9. And I know what the square root of 9 is. That's going to be 4 square root of 3 divided by 3. And now what I did is that I got rid of the denominator. So the denominator now is, with the root, is now gone. Okay, that's the whole process of rationalization. Right now, it probably makes absolutely no sense why we want to do that, but this is what the process is. Okay, all right, let's try another one. So let's say we had 3 over square root of 2. Okay, so think about what is the denominator missing. Okay, so the denominator in this case is missing another square root of 2. So I'm going to multiply both top and bottom by square root of 2. So what I'm going to have is 3 square root of 2 divided by square root of 2 times 2, which gives me 4. And the square root of 4 is just 2. So you're going to have 3 square root of 2 divided by 2. And that is my final answer. Okay? All right, let's do a couple more problems. Let's say we now had 3 over square root of 20. Okay. Now, before you start putting times square root of 20, let's simplify this a little bit more. So square root of 20 can be decomposed into 5 and 4. And then the 4 can be decomposed into 2 and 2. So notice, let's reduce a little bit of this. So you have a pair of 2's that I'm going to take out. So I have 2 square root, what's left over the square root? This 5, so the 5 is left over. So notice now, all we got to get rid of is the square root of 5. So we reduced it a little bit more so that we don't have to multiply by square root of 20 and then do more work than what we need to. Okay, so let's multiply both top and bottom by the square root of 5. So I'm going to be left with 3 square root of 5 divided by 2 square root. 5 times 5 gives me 25. So this is going to give me 3 square root of 5 over 2 times 5. And then 2 times 5 is going to give me 10. Okay, so that's going to be my answer. Okay. Alrighty. Okay, let's do another one. So let's say we had 1 over the cubed root of 6. Okay. Well, here, now we are looking for triplets, right? Because before we only wanted 2. a pair. Now we want a triplet. So now there's one lonely 6. The 6 cannot be decomposed anymore because it can be just 3 and 2. Nothing's going to come out. So it's as further reduced as it needs to be. So what am I missing? Well, I need 2 more 6s. Okay, so I need 2 more of these 6s. So whatever I do to the bottom, I also have to do to the top. So I need 2 more 6s. Okay, so on the top, I'm going to have the cubed root of 36 divided by, well, now I have 3 6s, so I have the cubed root of 6 times 6 times 6. I can take all of these out. So I have the cubed root of 36 divided by 6. Okay, and that is my final answer. Okay. All right, let's do a couple more. Let's say we had 1 over the cubed root of 4x. Okay. Now, can this be further decomposed? Yes, it can. It can be decomposed as 2 and 2. Okay. Now, notice, I can write this again as 1 over cubed root of 2 times 2, and then an extra x. Okay. So now think about it. What else do I need to be able to take out a triplet because it's a cubed root? Well, I need an extra 2. That's what I need. Okay. So this one, I know it has to be a cubed root. I need an extra 2 because then I can take it out. How many x's do I need? Well, there's 1 x here. I need 2 more x's. So that's what I'm going to multiply both top and bottom. 2 and then 2 more x's. Okay. So what I'm going to be left with on top is going to be the cubed root of 2x squared. Okay. Now here, I'm going to have the cubed root of 2 2's. And then I add another 2. And then 3 x's. Okay, so what I'm going to be left with is the cubed root of 2x squared divided by, now this is going to go outside, so is this one. So I'm going to be left with one triplet of 2's and 1 triplet of x's. Okay, and that is my final answer. Okay, so let's just try one more problem. So let's say we had something that looks like this, 5 over 2 minus square root of 3. Okay, so these are a little bit different because now you don't want to have a you're not missing anything. Instead, what you have is a 2 minus square root of 3. So what you're going to do, you're going to multiply by something called the conjugate, and you'll see why this is useful. And I'm running a little bit high on the time, so I'm going to do this one in the next video. Okay.